Hi, everyone. Welcome to my talk on testing a data science model. I appreciate this is an emerging area, therefore I found it quite useful to actually share my knowledge with you. I've actually done some research and asked some colleagues around the world who are in testing if they've actually been involved in testing a model or a data science model. And most of them came back saying that they're aware of this, but they've not actually been working in these teams. So I thought that's a great opportunity for us to actually get into. And in this session, my aim would be to actually give you an overview of what this is and try and inspire and guide you to see if you might end up liking this area and you could actually go and explore. So without further ado, let's get started. First of all, a little about myself. I've graduated with a BSc Honours in Computer Science. I fell into testing. I had no idea what testing was. And today I've got more than 7 years of experience and I find it really, really interesting to learn and to share. I've worked within various industries, as you can see, and some of my hobbies include dancing, yoga, teaching, and baking. Today's session would include information about what is a data science model, some background, the process around testing it, and some useful tips and complexities that I've come across and how those could be useful for you. Some stats. Currently, 80% of UK business are looking to hire a data scientist or seek data consultancy. IBM anticipates that data science will account for 28% of all digital jobs by 2020. This is great. This is a great opportunity for us to actually go in and validate those models and understand what they are. So what is data science? In a nutshell, it's a collection of tools and algorithms to understand hidden patterns from raw data. It allows decisions and predictions to be made, and the aim of making informed decisions, basically. So data science is more of a forward-looking approach. It works with real-world scenarios. It's an exploratory way with the focus on analyzing the past or current data. And it uses predictive analytics. Some teams might be using this, so it's a buzzword for you, predictive analytics. Organizations can find and look into patterns contained within data in order to detect risks and opportunities. What is a model? So let me give you a quick analogy. Imagine you're commuting to work in the morning. You sit into your car, you put your seatbelt on and you start. So that is your driving experience. So that's the data side of things. You need data for the model. Then your brain would try different driving patterns to learn what works best. So if you're faced with traffic, you would find the best route to get out of the traffic. So that's the computing side of thing. And the model side of thing is an equation of data inputs affecting your target value. In this case, how long it takes for you to get to work. So if you got to work sooner, your model worked great. But if you got to work a bit late, your model needs training. Let me give you another example. Example is for a manufacturing firm. You can check what they sold last week and then check what if they use the same assumptions that were used then, what would be an acceptable sale for next week. This is basically sales data of a client to improve their production. So data science modeling, what it does, it assesses the set of conditions and it guides you to make informed decisions. Now, remember, a model is a statistical black box. It's full of funky algorithms, and it uses probability distribution to understand the behavior of its inputs. It's more of a what-if model. So if a customer uses a parameter for the model suggested, then what their business could look like. It uses genetic algorithms as well. So genetic algorithms are algorithms that reflect the process of natural selection, where the fittest individuals are selected and inspired by Charles Darwin, actually. So yeah, a model produces some indications that are being used as guidelines for your clients. And each model would use configurations or parameters per the client requirements. So what we do as testers, we actually test towards the expected outcomes and see if they're actually in line with what we need to provide or they're actually not. So we need to raise those as concerns. So the benefits of data science model is to help craft better decision-making, identifying opportunities for businesses that they were not aware of, actions based on trends to help define goals, data-driven evidence, identification and refining of target results, so you're training your model, and mimics real-life scenarios. A model needs data, and the data, as you can see, is in 4 different styles. So structured data is it adheres to predefined data models. It's easy to aggregate data from various locations and databases, easy to store, access and process it, just like Excel files. Then you have unstructured data, which is not organized in a predefined manner. It's got irregularities in the data, therefore ambiguous as well. I use unstructured data, and it's important. What we have in our team is data schema, where the data engineer provides a data schema that we send to the clients, and we receive the data in terms of that data schema, which reduces any data biases. Then you have semi-structured data, which is self-describing data, uses tags and markers such as JSON and XML files. And lastly, you've got metadata, which, for example, could be photographs, and it provides additional information about a data set by telling you when it was taken and where it was taken. A basic kind of architecture here for you, and the scenario we will use is, imagine you are providing money on credit. Then the probability of customers making future credit payments on time is a matter of concern to you. So what you would do is you would push in the raw data from the clients. You would obviously have features on top of it that are doing what the client requires. You have your learning algorithm, which is the predictive analytics side of things. So just a little recap of what this was. It's a use of statistical and machine learning techniques to identify the likelihood of future outcomes based on historical data. Organizations use this to sift through current and historical data to detect trends and forecast events and conditions that should occur at a specific time. And then comes your model side of things with genetic algorithms. Now, genetic algorithms cause a bit of stochasticness, which means randomness. This randomness does not essentially have to be wrong, but if you have an acceptable deviation set in your team as a process, then these could still go ahead. And then it provides you some future-like data if you're using predictive analytics in your team. So here you can build a model which can perform predictive analytics on the payment history of a customer to predict if the future payments will be on time or not. Now, before we start testing, it's important to not have the elephant in the room. Make sure all of you have the requirements and you understand the requirements in the same manner. You're all on the same boat. So have requirements gathering sessions, have planning sessions to brainstorm possible solutions, design and prototyping sessions, go and implement the model and actually test it at every stage. Don't leave testing till the end. And what you could do is, if you're in an agile team, you can use the 3 Amigos session to actually understand the problem the client is facing and how you can best provide a solution. Is the solution good enough for the client? Is it testable? Is it not testable? These are the kind of questions and ambiguities you can ask in these sessions. So let's get started. So a model can be of 2 types. It could be off the shelf or custom made. In my team, we've got a custom made model. Depending on what you use, you need to understand that you should have processes around testing for it. Also, you should consider how often you're going to train your model. So what I mean by training is you input data, you run it, and you observe the results and see if they're good or not. Also, as I've mentioned earlier, because of the use of genetic algorithms in the model, it would provide a bit of stochasticness, a randomness. So let me give you a small little analogy again. 5 plus 3 for me and you is 8. But for the model, 5 will go in as it is, and it will output as it is. 3 will go as it is and output as it is, but the result 8 would be 8.00001 or 8.00065. This, when you see it, you might think it's wrong, but if you've got thresholds in your team, so say, for example, you accept deviations between 3 and 5% of your actual results, then this is not essentially a wrong result. It's within your cap of threshold. So you can still go and accept it. So that's the type of stochasticness you might face for some type of data set that's running through the model. Some testing then. So verify the data set that you use for the model, have some understanding of what this data set is and what are we trying to provide. Validate the input versus output data results, understand the shape of your result, and make sure the values are of the right type and the data columns are matching where they should match, and stochastic where they should be random. Test the areas you're certain about and uncertain about, so happy path and unhappy path testing, and those which cause some uncertainty in terms of results or due to the randomness. Make sure the results are within threshold, and make sure you get the thumbs up from the data scientists as well to understand that this is an acceptable result we can pass forward. Make sure the data pipeline works as expected, so no data is dropped or duplicates provided. And test using different parameters or configurations per your clients. So if you might have certain things that only accept strings, try and put some integers and see how it behaves. And lastly, explore the model, understand the model, just go in without any agenda, try and see if you find any underlying bug that you never knew about. So these are quite important things. Some more things that I've come across when testing data science models is new feature testing and regression testing. So when a new feature comes in, there's nothing to compare the model run to. Since it's a new implementation, you may find more issues around it. So try applying different configuration parameters and edge cases to understand the model outputs. If you do end up finding bugs as well, make sure they're not repeatable. Make sure they're solved once and for all. Work on a test plan with a data scientist and understand what is actually being implemented. Consult your results with a data scientist for more conciseness. The logic is tested in the unit tests. Run a model prior to a new feature and after. This is what I tend to do. So what you would see is something before would have less optimized results, and after you might have better results. Maybe the model took less time for a certain thing in your new implementation, and it gave you better results. And of course, exploratory testing. In terms of regression testing, what is regression testing? So you can confirm that a recent program or code change has not adversely affected existing features, and make sure bugs that were opened in the new feature are completely resolved. So what I tend to do here is I have a baseline run that I would potentially run in the previous release, and then I would create a new run and make sure they align. And if they are slightly bit different, that's okay, within the threshold of 3 to 5%. But if they're way too different, then you need to make sure you mention this to your team, and you can actually deep dive further with the data scientists and see what actually went wrong and if we can actually release or not. Remember, some models can have degree of randomness, so some areas would be expected to be random. Don't worry, deviation doesn't mean negative at all. If you have thresholds, it can still go ahead if accepted. No equation for the best answer exists, and rely on a good enough and fast enough answer. I know some of you may be thinking around automation. In this area, there's two things. If you do need human intervention, then I would not suggest automating this. But if you do have thresholds set, then you could potentially do some automation around that. So if the results are different to the prior release results, so if you have the threshold set, it would still potentially go ahead and you can automate that. But in terms of, for me and my team, my UI, I have a UI to run the model. So we can automate the front end side of things and run the model from the front end. So that's doable. Some useful questions and curiosities I had, so I thought might be useful to share with you. What is an acceptable test? Has a run completed and nothing broke within various stages of a model? Have we found anomalies? Did we drop some data? How do we know what we produced is the right result? How accurate are my results? What is an acceptable deviation? So all of these can be answered when you ask within your team, therefore be vocal. And other than that, what I would say is, how do I know I've produced the right results? So if you have a baseline run and you compare to it and you are kind of aligned, then that's good confidence. You've got great confidence there to actually go and provide those results forward, or you can be confident with those results. And in terms of deviation, if you've got thresholds in place and you've actually mentioned this to the data scientist that it's between a threshold, is it okay for me to pass this testing or not, then that's another thing. So stay in good communication with your data scientist and get the thumbs up from them as well. Let's practice this. So these are some locations and some birds in these locations. So what you need to understand is we are going to input this into the model and then see it in a dashboard if that's what you're using. So we're going to basically input the locations, which will be exactly same in the output, but the number of birds in each location may change. So this is just a visual example. I'm not going to do any technical check here. So the questions you should ask here is how many birds were counted on the 7th site, for example, 7th site? What is the total number of birds counted across all sites? What is the average number of birds seen on a site? These are the kind of questions you would come up. And then would I expect an increase in site A1 or would I expect a decrease? This is not predicting things. So that's useful. And then at the end of it, when you finish your testing and running a model, you should understand, have I got a good understanding of what the model has provided? Have the predictive analytics and the genetic algorithms worked as expected? Does the shape of my data look good? What I mean by shape is not triangle, square, or circle. What I mean is a histogram or graph. Does it look good? Have I got any outliers? And if so, are those outliers acceptable or not? What I tend to use is the mean, the standard deviation, the absolute difference, the percentage difference to help me validate my results. Some complexities I've come across are around data. So if you've got less clients, the best option would be to have synthetic data set or a golden data set for some of you, as you may know it, and mimic your client data, but respect the policies of the client data. Now, if we anonymize, make sure the file size is matched to the client's file size as well. So if you are anonymizing 50 characters, make sure you anonymize the 50 characters. What I did was I anonymized 50 characters down to 10. So some product description that was 50 characters, I wrote it down as description 1, 2, and 3. So that changes your file size. So try and stick to the exact file size your client has, because then you are reducing another potential bug of what the files or the data size that can be accepted into your model. Also, the model is quite complex. I don't expect you to know everything about the model, but have good understanding. That's vital. Knowledge silos. So some people may know a lot, some might not. So it's okay. Just try and be vocal. Make sure your questions are answered and make sure you document things as well. Dependencies. So there might be something that you might be building in the back end, but it may not have been mentioned to the front end developer. So make sure this is mentioned and you're not blocked. Your testing should be smooth end to end. So just make sure dependencies are captured, and this happens usually in the requirement side of things and the 3 Amigos session. Some tips for you to take away. So make sure you understand the data from a business point of view. Don't derail. I know that your model mimics real life scenarios and there's tons of assumptions. Assumptions limit scope, basically. You cannot pick all assumptions realistically because then you are derailing and what needs to be delivered won't be on time. So make sure you stick to your consumer requirements. Also, review and analyze a lot. So your specifications, you define your test scenarios, execute test scripts, review them, report and document if vital. I've been asked before if data science model testing can be done in agile, so in sprints. I've got 2 weekly sprints and it's possible, so definitely it can be done in sprints. Also, be ready for discrepancies. Just because a discrepancy sounds negative, it doesn't essentially mean negative. If you've got thresholds in place, that's all good. Some teams might need more precise results, so just reduce your threshold. Don't make it 3 to 5, make it less, 1 to 2, or just up to 1% discrepancy. Deviation. Also, by providing these statistics and facts for employees and clients that they can access at any time, you are creating a smart and savvy team that can use these insights to drive more business. And once you have a process in your team, stick to it and try and look for ways to optimize it. We are not just optimizing the model here, we are optimizing the team as well, in a way. Also, be present in all vital meetings. It's okay not to know everything. Pairing is useful. Raise your concerns wherever you find something that you don't understand. Make sure new features are being released often and bugs are not repeatable. And what does this leave me with? A hybrid tester, because I came in with testing knowledge and I've gained data science model validation knowledge. So we are hybrid testers here now. Okay, lastly, some useful tools for you to take away is SQL, if you're using databases, some statistical knowledge. You don't have to be a pro. You can do most of it on Excel, by the way, the statistics, the basic ones. If you're using a front end to drive your model, then developer tools would be good to check your endpoints. And Miro dashboard if you're doing any 3 Amigos session. So a little summary. Basically, aim to do some edge case testing and exploratory testing in your model. Make sure the model is providing accurate and precise results. And if you have thresholds, it's any deviation is within the threshold. Make sure the model can perform at a scale with new features. So make sure the model is maintainable as well, because if new features are coming in and your model is slowing down, there's something that's not happening right. Make sure it's still behaving as it is and it's not taking too long and no new implementation is impacting it negatively. So that was all from me. Thank you very much for attending my session. Please feel free to connect with me. I'd be happy to help you and share some more knowledge and learn from you.
Thank you, everyone. I hope you enjoyed the session. I'll be happy to take any questions.
Laveena, your voice is echoing.
Can you hear me now?
Yeah, it's better now. It's not echoing anymore. So in question and answer, setup, you can find.
Yes, I've got quite a few questions on the right side, so I'm going to start answering them. I did miss.
Your voice is echoing again.
Okay, shall I just mute and is it better now?
Yes, it's better.
Okay. So the first question, how easy it is for testers to get into data scientist path? What skills one needs to have? Right. I had no skills. So I fell into it when I was in my interview. They didn't tell me it's going to be a data science project. But I think because of your data scientists and the developers, the data engineers, you can actually sit and pair with them, sometimes, and you can learn from them. What does this algorithm do? What is behind this business logic? How do I understand it? And then I started making notes, and that's how I gained knowledge. And that's where I thought, right, this is an area where we need a lot of testers involved. We can't just test the end product. We need to be there from the very scratch. So I would say you don't need to do a course or anything. If you do want to read up on things, and if you do want to kind of learn on the back, like on weekends or something, then I would just say try some Udemy courses. Even this book is quite handy. Most of you may have seen this. It's by Eran Perforce. And it's quite useful because it's taking you through all the AI, ML, data science-y kind of talks by loads of speakers in this book. So it would be quite nice to even read a book like this. So I hope I've answered your question. Question number 2, how can testers position themselves if they don't have data scientists in the team? Right. If you don't have a data scientist in your team, but the product is coming from a data science area, I would suggest try contacting them, because the more you collaborate with them, the better it is for you to actually understand the product and understand what possible testing scenarios you can have, and how can you kind of find a small little bug where you might have thought a bug might not exist. So it's useful. I always say pairing is caring. I would definitely say try and find that team, even if it's offshore. Connect with them, have that kind of conversation going on so that you can understand whatever they're building, how you can test it at the end of the day, because we are like a safety net, right? We can't just go in and test a product that's given to us. We need some background knowledge about it. So I would definitely suggest find them and start talking to them, and even get your other team members involved, because other people might have questions, ambiguities. So this is the best time to actually get those resolved. So I would definitely say 3 Amigos session is a must. Right. I think the questions are moving up and down, but I'll try and answer all of them. Who usually sets the test data, developers or testers? So, right. It's a mix. When I was in the part of the data science team, I actually anonymized all the client data and chucked the real client data away, just to be sure with all the policies and we're not keeping any client data on our systems. So I actually anonymized it. It is a long-winded process, but after some time, when you have a bigger set of clients, you might think around synthetic data. So the golden data set, what they call it. So you can even build that with your team. You can have your main features, your edge case features, so that you can create the data set accordingly. So I would suggest it's a kind of a relationship between developer and tester. So the tester can be like, right, we want to capture edge cases and these particular features. So we need to manipulate the data so that we have all of that. So I would suggest you can do it yourself, or you can also do it with a developer, because they might have another set of knowledge that might be handy to you. So I would say it's a two-way thing. Don't just stick it to a tester or a developer. I would say if one has knowledge, the other can do it, or the other does it and the other one has a knowledge. So don't always stick to one person. Right. Is it necessary for a data science model tester to have mathematical background, or is a generic tech engineer sufficient? I would say a generic tech engineer is sufficient. I would definitely suggest read up on things that you do not understand. Data scientists tend to use business logics that are out there in Google that you can search. They can be a little tricky to understand initially, but don't feel worried, because if we concentrate all the time on the business logic, we are just derailing from what we are supposed to be doing. So make sure that you can have a conversation with your data scientist and data engineers of, what am I trying to test here? What have you done in the model that would impact my front end? Or if it's not impacting the front end, how is it improving the back end? And how is it improving my results? Are my results getting richer? Are my results getting worse? What's happening? So I used to go with so many questions, and they knew Laveena's going to bug us with questions. So it's always good to do that, because you get more kind of results out of it. You get a better understanding, you know what exactly to test, how to test. So I would say just bombard them with questions. Okay, more questions. What are the types or examples of bugs to find? For example, in a UI, we know the requirements and we check if they are respected. In data science, how does this really work? Right. In data science, it's all data related, right? So you might have graphs in the UI, which might look, wow, like really funky and nice, but are we confident about the results it's showing? So that's where you kind of see your integration level tests, and you actually check your backend data warehouse to see if they're matching. That's one check. The other check would be, it might be printing the wrong kind of information that you don't need there. That's happened quite a lot of times. So that's that. Other times, look at cosmetic issues, right? Look at cosmetic issues of how it's being represented. If you click on a button, is it adding an extra space somewhere where it's not required? Small things like that. Even like your URL, if you're changing tabs, is it actually reflecting that or not? So these are small things that you should always look into. We have tooltips. So every parameter has a little icon there. So I actually go and read it and I say, right, do I understand it? If I don't understand it, how is the end user going to understand it? So I need to be very clear. I need to ask the front-end developers, the UX designers, and the data scientist and the product owner. If I'm not getting it, then how am I expecting my client to understand that? And that's where it's really handy to do usability testing. That's where we learned certain words are quite technical for our end users. So I would definitely suggest bringing in usability testing and looking into that. Right, next question. What to learn in order to move towards testing data science model? What are the automation tools that you would suggest? Right, so in terms to learn around testing, bring your testing suitcase with you, because that is super useful. Always be curious, always do exploratory testing when you get a chance, because you never know what you might find. Usually on my day-to-day, I'm testing a feature, right? So I'm always, I've got it in my mindset that, right, I have to test X, Y, and Z to reach to my result. But on the days where I'm not testing a feature, I can just go into the product and I might find an underlying bug that no one saw earlier because everyone was busy doing their feature testing. So do loads of those kind of checks. And then in terms of automation tools, you can use Cypress. Cypress is a good check. We are using Cypress for the UI side of things. It also has embedded API side of things, so it's quite useful. I would suggest look into Cypress for those kind of front-end related checks. Programming language skill is not required. Right. Yes, it's not required. As testers, we are not supposed to be like developers, if you know what I mean. If you have knowledge, excellent. But if you don't have knowledge, don't worry. You can learn few things on the job as well. Like when I joined, I had done SQL ages ago. So when I joined, I had to get back to SQL. And I noticed that the data scientists were offering help. And they said, if you need any help with querying, because the queries are quite complex and you need to join complex tables and stuff, we will help you. And they did actually come forward and help. So that was really kind of them. So always look for as much help as you can. Don't always feel that you're under pressure for coding or anything. Don't feel that. So I hope I've answered your question there. Has your testing been affected by legal data compliance acts? In South Africa, we have the POPI Act. If you have managed this before, do you have some ideas how to manage it and share what issues you had? Right. It's a great question, Nick. We've not had that because we are not using client data directly. It's only the consultants who deal with clients, they use their data. So I always have anonymized. I've not used a client data unless I'm reproducing a bug in production. So I've not come across that, but I'm sure you could bring in strategies. Strategies are useful. So if you bring in strategies, how to deal with that, that would be great for your entire team. And it could actually help everyone understand better. So I would just say, look into how to strategize that, look into how you respect the client data and that you're using it for what you need and that is it, and then it's chucked away if you do not need it, because of course policies are there and you need to respect them. Has it been answered? Who usually? Yes, I did answer. Who sets up the data, test data, and developer, the developer or the tester? It's not a one-way thing. Both can be involved. You just need to make sure what you need to capture in your test data. Can the backend testing be automated? Yes, the backend testing, as I mentioned in my talk, sorry, can be automated, but you need to make sure if your model is not stochastic, then it can be automated for sure. Like my results, when I was checking regression, last release regression versus this release regression, I was just literally putting the details that I needed, my run IDs, and I was pressing the button. It would come out with all the all the kind of errors that we've had from last time to this time. And if they were threshold related, then we would ignore them. But if they were like quite big, massive thresholds, like over 10%, then we would, or like even 5%, we would be like, right, something's fishy. Maybe my parameters were wrong or I've messed something up. But I would definitely suggest you can automate the backend side of things, but just make sure if it is a random model, then you have your thresholds set. Aftab, can I answer more questions, or you're here to tell me that time's up?
I wish I could allow you more time, maybe a question or two more, definitely. And then when we have the break, you can answer the rest questions. You can answer 2 more questions.
Okay,
I'll give you that flexibility.
Perfect. In what the data science is different of regular UI integration testing? So it's not very, very different. I thought it would be quite a big kind of area where it might be very different. But if you come in with your testing skill set, you're doing your integration level testing, whether it's with Postman, Swagger, and doing your unit tests and also automated checks, I think it's quite similar. It's just the part of the model. The model is where you need to start thinking differently, and you need to think like, you need to put the data scientist and data engineer's hat on, because things are very different. You're working with a lot of data. You can have a lot of biases as well. So one thing I would definitely suggest is work closely with your data engineer. If they're changing anything, you should know, because that would impact your end results. So I would suggest that, but it's not very different. slightly different, but the slightly different you can do by learning extra on the side or collaborating with the data scientists and data engineers. Right. How about logistics you write for data science model for validations? Is it totally as per the requirements, or do you calculate your expected result? So I was doing a lot of manual results validation, and it was very Excel heavy, and I was getting quite annoyed, and I was like, right, this is taking too much time. We need to think of other ways to improve this. And that's where I went up to the data scientist and I said, is there any way we can automate this, like check last release results versus this release and see what differences we've had or what's improved, or check the quality of our results. So that's where the automation side of things came, and you can definitely automate that. The test, obviously the data scientists work very closely with Python, so the automated checks were Python related. Right, I'll answer this last question because it's my third question now. What is your role while training the model initially? How does your test data differ from the training data? So in terms of training data, we always had like the first client's data that we were using for training. And as the parameters kept changing throughout, because we use a lot of parameters to run a model. So as the parameters kept changing, we kept twiddling around with some data, but everyone was aware of it. And if we didn't need to twiddle with the data, then we were just making sure that the parameters work as intended, because sometimes they break as well. So we need to make sure that they are not flaky. So it's important to kind of, I understand some teams have training data. Our team did not have training data. We just worked with anonymized data set of a client that we were piloting at the time. So we actually used their data and anonymized, obviously. And we just kept training our model with it by using different parameters. And what you do other than that, you know, when you're kind of using different parameters, your model might run faster and slower. So you're passively doing performance testing at the same time as well. So that was another thing that I found out whilst doing. So I was like, right, Laveena, you're doing a bit of performance test here as well, because you're playing with these parameters and seeing what the results will look like and how the backend acts for that.